Let's get rolling. All right, now, the whole idea starting off is probability. All probability is really just a measure. I'm going to use black. A measure of the likelihood of something. So, how likely is that to happen of an event, or an occurrence is another way to say that. So, a lot of times you hear things like there's a 30% chance of rain tomorrow. Well, they're giving you, that weatherman is giving you the probability that it's going to rain. You have a 30% chance, or a 3 out of 10 chance, or a 0.3 chance that there's going to be rain tomorrow. Or you might hear when it comes to the lottery, you have a 1 in 10 million chance of winning the lottery. They're not very good. That's not a very good chance for you to win, but that puts it in perspective. One person will win out of every 10 million people who actually enter. So that's basically what probability is. It's just the likelihood of something occurring. So let's go on to that reteach 9.1, and you can follow along with me. Now, probability is used in lots of different areas. You can look at it as a percent, you can look at it as a fraction, or you can look at it as a decimal. Since we just finished percents, you know how to convert among all three of those. So again, it kind of explains what probability is, but there's two terms here that you need to know. Event is the specific event or occurrence that you are looking for. So the probability that it will rain, that's your event. The probability that when you roll those dice, you're going to get a sum of 7. The sample space is how many possible ways it could happen, not the ways that it could happen that you want. It's how many ways could those two dice land, or how many different combinations of heads and tails can you get if you flip a quarter 5 times. So all the ways it could happen is your sample space. The ways that you want it to happen would be your event. So for example, here's a little spinner that has A, B, C, and D on it. They're equally spaced apart, so each one is the same size. So if I were to spin that, my sample space is how many ways could uh, could this occur if I'm just spinning the spinner? Well, or how many different ways would it could it land on something different? Well, there's an A, a B, a C, and a D. So your sample space is 4. There's 4 different things that could happen total. Now, if I want a specific occurrence or a specific event to occur, then I want to know how many ways that could happen. So um, if I said the probability of landing on A. That's what that means, the capital P with the parentheses. That means the probability of A occurring. Well, if you spin that spinner, there's only one A on there, so that means there is a 1 out of 4 chance that you'll get an A. So this is your sample space down here. This is how many ways can you get an A. There's only one. Same thing with B. There's only one way you can get a B because there's only one B, or a C, or a D, and so on. So in this case, this is equally likely that you would get an A, or a B, or a C, or a D. You have a 1 in 4 chance, or 25%. So let's go on down to the next section. It says, complete to give the probability for each event. List all the possible outcomes if a fair coin is tossed. So if we just flip a coin in the air, how many possible ways could it land? Well, it could land on heads, or it could land on tails. There's really only 2 ways that could happen. So how many outcomes are in the sample space? There are 2. The probability that you would land on heads, well, there's only one way it can land on heads, so you have a 1 out of 2 chance of flipping that coin and getting a head. All right, now number 2 is a number cube. This is also known as a die. That's singular, or dice would be plural. So we were just talking about dice, but we're only talking about one, so it's called a die. A number cube is rolled. So what are all the possible outcomes? Well, your typical number cube has how many sides? 6. So it could land on 1, or we could have a 2, or we could have a 3, or we could have a 4, or we could have a 5, or we could have a 6. So how many outcomes in the sample space? Well, there's, count them, 6. What's the likelihood or the probability that I'll land on a 5? Well, you always put your sample space on the bottom. So out of the 6 possible ways that could land, how many of them would be 5? Look at your choices up here. There's only one way you're going to land on 5, so you have a 1 in 6 chance of rolling a 5. All right, nothing too complicated there. All right, so let's go on to the next section. And this just goes into what is impossible versus what is absolutely certain to happen. So if you have a probability of 0, that means your event is impossible. There's no way it could ever happen at all. So on the spinner, what we were talking about before, this spinner that has an A, B, C, and D on it, what's the probability that you would spin an F? Well, that's 0. That's totally impossible because there's not even an F on the board. So it's not likely at all. A probability of 1 means that the event is certain. It means it has to happen. There's no chance that anything else could happen. It's 100% certain that it will happen. Well, in one roll of a number cube, what's the probability that a whole number from 1 to 6 is rolled? Well, of course, it's going to be 1 or 100%. That's the same thing as 100% because that's all you have on a number cube is 1, 2, 3, 4, 5, and 6. Okay, so a couple other examples. Well, what's the probability of selecting a rectangle from a set of squares? Well, that means you need to know a little bit about how squares and rectangles are related. So if I have a whole bunch of squares to choose from, here's a square, and so on and so on. What's the likelihood if I choose one of those that it will be a rectangle? Well, first thing you need to know is, by definition, what makes a rectangle is it has 4 sides and 4 90-degree angles. Well, every single square is also a rectangle. So if I draw one of these squares, what's the likelihood that it's going to be a rectangle? It's certain that every single one of these squares is a rectangle, so the probability here is 1. How about this one? Selecting, what's the probability that you would select a negative number from a set of whole numbers? So you have to think way, way back to the beginning of the year. What are the whole numbers? Well, whole numbers are 0, 1, 2, 3, 4, 5, dot, 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 so on, so on, so on. What's the likelihood that if I were to draw one of these whole numbers at random, that I would actually select a negative number? Do you see any negative numbers there? Yep, me neither. So that means there are no negative numbers. That means you have a 0% chance or a 0 probability that you would select a negative number. Okay, and the very last part is the sum of the probabilities of all possible outcomes in a sample space is 1. So if the probability of snow tomorrow would be 30%, then the probability of no snow is 70%. Makes sense. They just have to add up to be 100%. The probability of snow plus the probability of no snow has to equal 1. So in our last two examples, if the probability of selecting a senior for a committee is 60%, so we would write that as the probability of a senior is 60% or 0.6, you could put it that way, then what's the probability of not selecting a senior? So the probability of not a senior. Well, these have to add up to 1, so if there's a 60% chance that you will pick a senior, then there is a 40% chance or a 0.4% chance, or 0.4, sorry, chance that you will not pick a senior. All right, and last, if the probability of choosing a red ball from a certain box is 0.35, so probability of a red ball is 0.35 or 35%, then the probability of not choosing a red ball, so not a red ball, would be what? Whoops. It would be whatever the difference is between 100% or 1 and 0.35. So that's going to be 1 minus 0.35, which is 0.65. So if there's a 35% chance you'd pick a red ball, then there's a 65% chance that you would not pick a red ball. All right, so that's all there is to it. That's probability in a nutshell. Teeny tiny, quick little tidbit just to kind of give you an introduction. Now, what you need to do next is you're going to be on your own for this one. You're going to go on to practice B, which should be on the back of your handout, and then based on the information here, you determine what the probability of each of those events would be. You need to also read this section up here so you know. And keep in mind, there's a difference between greater than and greater than or equal to, and less than or equal to and less than. So use that information to your benefit as well.